Reconstruction from multi-view satellite imagery. That's the title. That's a mouthful. But what's the goal of all this? It's to build simple polygonal models out of satellite images, capturing the 3D structure of the world, as well as the identification of the different materials in the world. So that might be, in this case, yeah, good point. All right. So in this case, typically you'd come in, you get satellite images in, you process those through some photogrammetric method and get a point cloud, and that point cloud is enormous. They're hard to deal with. They're fairly noisy. They also don't tell you anything about what's in the scene. It's just a bunch of points. So with that, we want to take it and actually process it into what this does is labels the ground's green, the buildings are gray, roads and things are blue in that case. And when we've gotten that point cloud, we then want to photo texture it in a way that you can actually look at it and see, oh, these are buildings, that's a road, and it makes it very clear what's what. As part of that texturing process, we also want to improve the texture. And when you take pictures from satellites, you have things like shadows are an issue. So we want to deal with shadows and removing them. One of the techniques we do is render the scene effectively from the sun's point of view and figure out where the shadows would be in the images, and then not use those to texture the final model. And that's how you get this really pretty view with no shadows that then you can post-process to light any way you'd like. So this was work done, part of IARPA, that's the Intelligence Advanced Research Projects Agency, sort of the Intel community's version of DARPA, their CORE3D program. This program's about trying to make it cheap and easy to make these sorts of models for the entire world. So they started with a few locations in the US, and that's what we dealt with. So there are data sets out there available online that have labeled, they have the satellite images, they have semantically labeled maps, they have the correct identities of all the various buildings and this sort of thing. And the idea is to create, instead of, you can see the little no symbol there at the bottom, we don't want to make sort of, you take the point cloud, you run like Poisson meshing on it, and you get this blobby kind of thing out of it. That's not what we want. What we want are sort of above that, it's a very simplified building models that have nice square sides. The other thing we do is recover the shapes of the roofs very carefully. That's mostly what you see when you're looking from above. Roofs are can be very simple. They can be nice flat roofs. They can also be very complex with multiple sides. Like you sort of see here in the middle in that LOD2 picture. They can be domes, they can be curves. So we spent a bunch of time working on recovering that. The other thing we've recovered is using multispectral imagery is actually the identity of the materials in the scene. So, is it vegetation, is it, I guess, tar paper roof, I'm trying to metal, other things. But the big thing here is this data set's available, it's all labeled, it's wonderful. I guess I've sort of taken you through the goals here. That's what we've got. And, oh, I should mention too. Here we go. This is just an example of the public data that's up there that IARPA put out. So if anybody's interested in working on this particular topic, there it is. We had partners, various partners on this program, including Columbia, Purdue, Rutgers, Raytheon. We were the prime on it, and worked on this for about a year. And let's see if this video plays. I hope it does. Yeah. All right. 3D models are great when you look at them in a picture, but they're a lot better in a video. So yeah, here are the satellite images. We have, so we know where the satellites are placed. We have the pictures. We can take those, recover a 3D model, and here's sort of the point cloud generation step. Isn't it cool? It's all raising up out of the ground there. And we're going to spin around so you can get a feel for what's really recovered. So you see, we do get lots of tops of buildings. Not their sides very much, and that's a problem if you want to make a model. We can take this, we can color it by the height, and yes, here, a digital surface model. This is an estimated terrain. From that, it's effectively like low-pass filtering the point cloud. Here's our segmentation. As you can see, and they're all labeled. And this is the material classification. There's a little key up there on the right. I won't quiz you on what all those are. And the final textured model. Okay. Yeah, one of the upshots of this too is this was fairly inexpensive to do, and $10 per square kilometer, run on AWS, so you could potentially do this on much of the world if you had enough budget. Here are some of our results. This is in San Diego, Jacksonville, downtown Omaha. How am I doing on time? I'm out. All right, I'm out. Texture rest results, and I'm done. Here's the software. It's open source. It's free. Come use it if you'd like.